Now I want to discuss about this hypothesis testing, but in a different situation. My previous 3 lectures I have explained when you have to compare one sample with respect to the source of the known variance with respect to the source of unknown variance, and comparing 2 samples having the known variance of their respective source. Now we want to take a situation where sample data are known to us. However, the source properties are not. When source properties are not known, only the difference we want to see whether the difference between the source mean of both the samples significant or not. We want to compare the performance of both tests with respect to other tests. One car's mileage with respect to the other car mileage. One material's hardness with respect to the other material's hardness. One sample hardness with respect to other sample hardness. Machining of one tool with respect to the other tool. So if we have such kind of examples where only source sample data is available with us and we have to perform the test. So in such situation, what we will do, what will be the steps of hypothesis testing? I'll show you one by one examples. There will be 3 examples which I will show. One is where we will use the source variances are not known, but they are supposed to be same. Another case, source variances are not known, but they are not same. The third case is where sample size has to be same, because it is very, very common type of t-test in research experiments, where we have to see intervention and post-intervention, the effect of design, effect of training, effect of any change in the design. So that case we call pairwise t, where the difference of performance pre and post intervention is very important to be able. In that case, the t-test is called as pairwise t. Look at the first one, then I'll show you the second one, then we'll go to the third one. It is for full sample based hypothesis testing, where only the sample data are known, with supposing that the source variance are same and equal. Source variances are unknown but equal. So treatment 1 and no treatment. When treatment was given to a particular sample and the treatment was not given to the particular sample. So problem I read out to you. Find out whether a new serum will arrest leukemia for 9 mice, all with the advantage stage of disease are selected. 5 mice receive treatment, 4 do not receive. This was set of data where mice had a treatment, here no treatment was given. Sample is not same. First set had the sample size as 5, another set has a sample size 4. But it is supposed that both had the same variance. So 1 square is supposed to be 2 square, but they are not. In such situation, we have to compare whether the mean effect of this is same as of the mean effect of this, because we have to see that whether the life of both are same or with the treatment the life is more. We have to perform test on 0.05 significance level. The alpha is given. There are certain steps for hypothesis testing which we have to follow, where difference is 0 or difference is, this is our null hypothesis that d0 is 0, and our alternate hypothesis that mu1 minus mu2 is more than 0. Here the concern is that if life is more, it means that there is a challenge of the treatment and that is being accepted. Null hypothesis is accepted the case when the difference is not 0, it is more than 0. For that case, we have to ensure the upper bound that whether the calculated t-value goes here. So here we will reject H0. We'll apply this alternate hypothesis for one-tail test. Will not apply this one. It will be one-tail hypothesis testing, and the procedure for calculating the t-value will be this one, with the difference of sample minus difference of mean upon the variance is supposed to be calculated that way and degrees of freedom. We'll solve this where our null hypothesis is mu1 minus mu2 is equal to 0. The alternate hypothesis mu1 minus mu2 is more than 0. So for this case, we have to calculate the value of t, value of mu degrees of freedom, because we are applying. We will apply t distribution because sigma 1 and 2 are unknown, but they are supposed to be. In this case, t is we require the value of S1 square and S2 square, and S2 will be calculated from this set of data. X bar will be calculated from this set of data, and X2 bar will be calculated. What are these values? We can see from the Excel. These are our values for sample 1 and sample 2. We can write it as this is 1.63. SP is known. The square root of SP is SP. So if we have to calculate the value of t calculated will be minus 0, because d0 is 0 here, divided by, that will come out to be this value comes as 0.412. You can say degrees of freedom was 5 plus 4 minus 2, that is 7. So for 7 degrees of freedom, now these values, if I draw the normal distribution with the mean value of 0, variance have 1.28, and if we fix this bound over here as a critical region, in this case our level of significance is given as 0.05 critical region, and that is our acceptance zone. This was alpha, or as level of significance, and this is called as confidence interval, which is equal to 1 minus alpha. That is, now if we transform into t distribution for hypothesis testing, what will happen then? We will draw distribution. This is t distribution with respect to new value of 7 and is 0. Dx is, if we define the critical region, over here. So this will be our alpha 0.05. This point will be called as T alpha. And now we have to see what is T calculated. T calculated is 0.412. This we'll see from table T distribution. And this stands for value n equal to mu equal to degrees of freedom 9 for alpha 0.05. The term calculated is this one. Sum from the table is this one. T alpha is 0.833 at alpha equal to 5 and mu equal. Now, what will be the decision criteria? Because as per the alternate hypothesis, T calculated is far less than, which means your calculated value goes somewhere over here, which is this acceptance. So that is why H0 is not rejected. When H0 is not rejected, then it means there is no significant effect of treatment on. That was our hypothesis testing one tail. So this was hypothesis testing based on T distribution for two samples where we were comparing the intervention of treatment. Both the samples were of different size. Source variance was supposed to be same, and because we want to see the change on one side of the life, that is why we perform one hypothesis.